Hello everyone, welcome back to my channel. My name is Radam Balik and you're watching Balik Robotics. So in today's video, we are going to cover a new algorithm of machine learning, which is support vector machine or SVM. These this video is going to in two parts, first and second. This is part one. Here we are going to see what is SVM and how we can it's like how it works and it's like what are its cons, pro and what are its pro and what are its application in real world. And in second video, we are going to cover what is kernel and how we can use SVM in non-linear data. So without wasting much time, let's jump to the video. Okay, so SVM. First of all, what is SVM? SVM is a wait, sorry. SVM is a type of supervised machine learning, and with SVM we use using for classification. But in some cases, we also use SVM for regression. So let's see how we can use SVM for classification and for regression. Okay. So first of all, supervised. In this series, I have already told you several times what is supervised machine learning. In supervised machine learning, we have input raw data, which is labeled. We give our labeled raw data to a model, and after training of the model, it gives us the trained model. In trained model, we provide the input and then it gives out an output. Like this robot is telling this is an apple. So now jumping on the SVM. What is SVM? SVM stands for support vector machine. And let's start with vector. What is vector? A vector is simply an array of a number that represent data, just like tensors and other form of numpy arrays that we have already studied earlier in Python or machine learning or deep learning. Okay, so this is an example: x equal to 170, 65. So this is a vector quantity. Scalar quantity is x equal to 170. But of course, SVM work on vectors, so we only use vectors. And what is mean of support? Support refer to support vectors. Okay, so this support vector define the position where our hyperplane or boundary will be set. Okay, so you don't know what is hyperplane or boundary? Don't worry, we will cover in this video. Machine. Machine is nothing but just algorithm or model. So support vector machine. This means that we use support vectors and a machine to predict an output. So this is our SVM or support vector machine. Here, this one is hyperplane, which differentiate our different type of data plane. But it doesn't look like this in actual. In actually, our SVM look like this. Okay, so we have some data point like blue balls and some data point like green balls. So what this SVM does, it make a hyperplane. This hyperplane divides our data set into two parts. Like the left side of our hyperplane is blue balls, and the right side of our hyperplane is green balls. And it also makes two boundaries, boundary 1 and boundary 2. So this distance is called a margin, and our the last result of the output of the training is that we can have a maximized margin. It's like as width of the margin we can get, we should have. So this is only how process of SVM. Now you will have a question that rhythm that we understand that this is a hyperplane and this is a margin, but why this is like this and not in straight? Okay, so there is a reason why hyperplane in this image is like tilted and not like this straight. So this is by the our definition. Our definition of SVM is like that. It tries to make maximize margins. Okay. Now if I rotate this image, let's see like this. Mhm. Okay. So now you can see that there is some space is still yet. So when we fulfill it, you can see that we have a greater margin than this. So that's why is in this case our margin is like tilted. This is the main goal of SVM, that it create a hyperplane and a margin of boundaries which separate our data point. And remember, this margin will touch the endpoint of our vectors. Okay, so in SVM, support vector are these points only. These balls are called support vectors, and the support vector r is like last point. It generally, the margin and support vector are connected. Okay, so in this support vector, one of the support vector connected to margin, where margin is there like this. Okay, but here it doesn't, our model will not predict this because it connect our margin, but this is not maximized. The maximized part is tilted one. Okay, so we have seen how SVM work. This was only procedure of the SVM. Now, uh, let's see some pros and cons. So first of all, it is effective in high dimensional space. Now you will ask, what is high dimensional space? So this will we cover when we cover what are kernels. Okay. Secondly, it still work when number of features is more and number of samples are less. So means, like when we have number of features which like this ball is yellow, round, and like this number of features are much greater, and number of classes are much lower. Okay, let's see if I say that this ball has 50 feature. SVM generally doesn't overfit. So this is one pro, that if we have many number of features than number of samples, like we have only 20 samples and there are 50 features, then also it doesn't overfit. It is memory efficient as it only use support vectors. What are the cons? That it doesn't like suitable for very large data set. Secondly, it is not effective when class is overlapping, like when yellow ball and pink ball have are on one and each other. Okay, and third point is choosing the right kernel and tuning is tricky. Now you will ask, what is kernel and what is tuning? So we will all cover this in the next video, where we will study what are kernel and what are non-linear SVMs. Okay, so some of the applications of SVM are text classification, like spam detection. It detected this email is spam or it is genuine. Image classification, like handwritten digit, like it's 7 or it's 8. Bioinformatics, like protein classification, like which protein structure it is. So this was all about HPM in this video, and wait for second video where we are going to study what are kernel and how we can use non-linear data. For your clarity, what is linear non-linear data? Linear data is the data which can be separated by a line, and non-linear data is the data which can't be separated by one line. So you can see that only one line can separate these two, but in non-linear data we can't separate it by one line. So how we can do it, and how we can code it, we will see in the next videos. So second video will be going like nonlinear data with SVM, and third video will be going on how to code these two. Okay, so I think you have a good understanding what is SVM. And if you are new to our channel, please subscribe our channel. If you're old, then give a like and share with your buddies. So we'll meet in next video. Until then, bye bye.